Hello everyone, welcome to another tutorial in fluid flow by Smart Blue Kites. In this fluid flow tutorial, we are going to look at determining the rate of flow in a horizontal Venturimeter, where we are given some parameters and we are told to use the parameters and determine the rate of flow in that Venturimeter. So let's bring out this data, then we are going to show them in a diagram that explains the Venturimeter. We are given D1, which is the inlet diameter, to be 200 millimeter, which is 0.2 meters, and a throat diameter D2, which is 100 millimeter, which is 0.1 meter, is employed to measure flow of water. The reading of a differential manometer connected to the inlet is 180 millimeter of mercury. So this is like the difference in the height of the fluid in the tube, where I will explain also when I'm showing the diagram, which is 180 millimeter of mercury. If the coefficient of discharge, we are given CD, which is the coefficient of discharge, as 0.98, and we are told to determine the flow rate, which is Q. So for flow in a Venturimeter, the flow rate is given by this formula. Q is equal to CD multiplied by A2 over square root of A1 square minus A2 squared times 2GH square root. That's the square root of 2GH. Now what are these parameters? Take a look at this diagram, which is the Venturimeter. We can see that from here, where they say the upstream, we have an inlet diameter D, which is from the data I've written, I write it as D1, right? And we have a throat diameter, which is the diameter here, which from the diagram I wrote it as D2. And the differential height I'm talking about, that is the height in between here and here of the mercury inside the tube. We can see that here they denote it as HM. It's denoted as Y, and in some instances as X. For here, let me write it as Y, which is 180 millimeter of mercury. And I'm told that it's mercury inside here. That's the differential is 180 millimeter mercury. We need to consider some things here. We are told that it's water that's flowing here. Water, it's mercury here. We will see how we are going to use that. Now let's go for the solution. We are told to determine the rate of flow, which is Q. The formula is given earlier as CD multiplied by A1, A2 all over the square root of root A1 squared minus A2 squared times 2GH square root. CD, that's the coefficient of discharge I'm given from the question, while for the areas, I'm going to use the diameters given. That is A1, area is equal to pi d squared over 4. So A1 is equal to pi d1 squared over 4, which is the same thing as pi my d1. That's the diameter of the inlet, which is given as 200 millimeter. That is 0.2 meters, 0.2 squared over 4, which I got as 0.0314 meter squared. At the same time, A2, which is the same thing as pi d2 squared over 4. D2, that's the throat diameter, which I'm given as 100 millimeter. That's 0.1 meter. That's pi 0.1 squared over 4, which I got as 0.00074 meter squared. So I now have everything from this formula except H. I also have G, which is the acceleration due to gravity, then this height. This height is not the differential manometer height, the difference in that mercury, but we are going to use it to determine the height. This height have two formulas, which I'm going to write now. The first formula to determine this H is Y, which is that differential height I'm given, into the specific gravity of the heavier liquid, or we can say the liquid passing through the Venturimeter over the specific gravity of the liquid in the pipe minus 1. We only use this formula if the liquid in the manometer tube is greater than or is heavier than the liquid in the Venturimeter tube or in the Venturimeter pipe. We can know which liquid is heavy depending on their densities. And the second formula for the height determination is almost the same, but we say H is equal to Y into 1 minus the specific gravity of the liquid in the manometer over the specific gravity of the liquid in the pipe, that's the Venturimeter. So we use this when the liquid in the Venturi pipe or in the Venturimeter is greater than or is heavier than the liquid in the manometer. So now how do we know which of the two liquids are there? It's given in the question. From the question we are told that it's water that is passing through the Venturimeter, and we are also told that it's mercury in the manometer tube from the English of the question. So water have a density of 1000. So what's the specific gravity of water is 1, while mercury have a density of 13,600. So the specific gravity of mercury is 13.6. So we can now see that mercury is heavier than water. Therefore, the height we are going to use, the formula for the height we are going to use is this: H is equal to Y into SHL by SLP minus 1, which we are simply going to say H is equal to, we are given that Y is 180 millimeter, that's 180 times 10 to the power of minus 3, that's in meters, into 13.6 for the mercury and 1 for the water minus 1, which when you press in your calculator, you'll see that the height, the H, is equal to 2.268 meters. So we have everything now. All we need to do is just to insert them in the rate flow equation, whereby the equation is Q is equal to the CD given from the question, 0.98, multiplied by the area 1, which is 0.0314, also times the area 2, which is 0.0074, divided by the square root of the areas, that's 0.0314 squared minus 0.0074 squared, then times the square root of 2GH, which is 2 times 9.81, times the height I just found to be 2.268, also in square root. Calculating this correctly, you will see that the Q, which is the flow rate, will give you 0.053 meter cube per second. This is the rate of flow. Do you understand this? Wait. Kindly subscribe to the Smart Bukites YouTube channel and press the bell icon so that you'll see more of our solutions. If you enjoyed this video, comment, and if you have any question, kindly state it in the comment section. We'll always be there to answer your questions. See you in the next video.